Hi, my name's Ed Hawkins, and today I'll be taking you through this week's question and answer session from us here at Innova Systems. Thanks for watching. So we've been asked how we can make a spring compress and extend within an assembly. You'll see here that I've got the finished article on the screen, and we will go backwards and discuss how we can create that in a moment. But let's first look at the movement. So if I pull these two components on the inside of this valve, you'll see they move freely along the central axis. If I drop those down and just rebuild the assembly, you'll see my spring increases in length. And if I drag it back in on itself and update that, you'll see the spring decreases in length. So we've got the type of behaviour that we want there in the component on the screen. So what I want to do first before we move into the animation side of things is take a look at how we actually physically create that spring. So I'm going to suppress the one we've got here, and we'll add in a new component. What we really need to do is relate a sketch between this face and this fixed face here. Okay, so we're going to do that in a new virtual component, so a component that exists in our assembly. So I'm going to create a new part on this particular plane here. Just make myself normal to that to make life easy, and I'm going to draw a sketch line between that point and that point there. Okay, so at present that line is fixed in terms of its length, so I can exit the sketch now. And what we'll see straight away is if we stop editing the component and move these two components here and rebuild, that our sketch line increases in length. So we've already got the behaviour that we want at sketch level, which is great, so we can move on to the next stage. I'm just going to query a dimension here first so we can see the radius of that circle is 6 mil, so diameter 12. So I really need to create something on the inside there to form my spring. So I'm going to open this component in its own window, and if we just zoom in and take a look, we've got our sketch on the screen like so. Now this sketch won't necessarily be positioned very well relative to the default planes because of how we've created it. So a good thing to do here is to add in a new reference plane, so we can just select plane and pick the end point of that line and perhaps another plane to make it parallel to, and that gives us a new plane to work on. And on this plane I'm just going to draw a circle. So we'll create a new sketch and draw out a circle here at a size of, we'll make this 10 mil for argument's sake. Okay, the reason I've sketched a circle is because really what we want to create is a helix for the spring to be coiled around. So what the prerequisite for a helix is a circle. So if we now go to the features toolbar, to curves, you'll see that helix and spiral is available to us, and you'll see it gives us a preview of that helix on the screen. Now at the moment this helix is driven by height and revolution, but it's going the wrong way, so we're just going to reverse the direction there, and that's fine. I'm not going to worry too much about the height for the time being. I'm just going to leave that at that value. What we really want to do is have that height change as the length of this sketch line changes. So we'll just go through how we can do that, but I'll just finish the creation of the helix first. So in this sketch it's dimensionless at the moment, so I'm just going to add on a reference dimension there and leave it driven, so it's a result of the behaviour of the other components, and then just exit that sketch. Once you've created something like a helix or a spiral, if you double click on it, you can actually see the dimensions that control it. So I can now double click on that 8.9 dimension, type equals to take me into the equation side of SolidWorks, and then select sketch 1, which will show me the dimensions that are available for that, and then click the reference dimension that I've just added. So now the dimension for the helix is referencing that changing dimension there. So if I just click the green tick to accept that, you'll see the helix has a little rebuild symbol on it. So if we just do a Control Q, we can update that, and you'll see the helix updates to reflect that change that we've made. So that now gives us the changing helix, and we'll see that in action in a moment. But if we just want to finish this off, one thing that we can do is we can start a sketch on the top plane, so this is the plane that intersects that helix, because what I want to do is create a circular profile on there to sweep along my helix to give us a visual representation of that spring. So if I just start a sketch and draw a circle, we'll just give that a dimension of 1mm, and we'll just link the two together. So we're going to use a pierce relation here, which allows the circle to pierce the helix, and we can exit that sketch and then use a very simple sweep here to sweep along the helical path like so, and we end up with our component. That's as much as we need to do at this stage, so I'm just going to save that and return back to my assembly. So we've effectively duplicated what we've got here, and once you've actually done that, what you'll see is, because the sketch line is always adjusting in length within here, that the physical spring is changing in length as well. The next stage for us, really, just to finish off the answer to this question, is to animate that. So I'm just going to come out of section view and make this component transparent here, just so we can see the behaviour. We don't want to see that sketch, we'll just hide it. And if I make a new motion study here, like so, just so we can see what's happening, I should be able to grab hold of those components. So one thing that we can do here is just move the time bar to a particular amount of seconds, and then I can grab hold of the component that I want to move and move it. And what you'll see is the system puts some keys in to signify that there's some movement between components. So it works out the transition between where the component was and where it is now. And if we solve that motion study, what we'll see is that the spring is being solved for every time step within the animation, so it is physically updating the geometry as it moves along its path. So it's a really nice feature within animation that makes things like creating springs or cutaway animations nice and easy. Thanks again for watching.